This is a video to show you how to do problem 11.42, which says that shoplifting cases in a certain town are randomly assigned to two different judges, and a citizens group wants to know whether either of the two judges is more likely to sentence the offenders to jail. So here's jail versus another sentence, something like community service or something. And then here's the two judges. Stark is one judge and Rivera is the other judge. And here's the set of outcomes. 27 here, 31 here, 65 here, and 57 here. So what we're going to be testing is whether these two factors are independent, the kind of sentence versus the judge. So we're going to say judge and sentence are independent is the null hypothesis, versus judge and sentence are dependent. Remember, independence is always in the null. We're going to use a 5% level of significance, and for each of these types of problems we're using chi-squared. So the next part is getting our test statistic. So for each value we need an expected value, so we need the total that goes with each row and each column. So our totals are 92 for Stark and 88 for Rivera and 58 for jail and 122 for another sentence, which is a total of 180. So expected value for Stark and jail comes from the row total, which is 92, column total is 58, out of 180 gives us a total of 29.64. Let's do one other one. Let's do the one for expected value for Rivera and other. Is that row total is 88, column total is 122, but it's also out of the whole sample, which is 180. So that's going to be 59.64. So you might like writing them in the box that they belong to. This one is associated with Stark and jail. So by a similar method, remember each expected value is row total times column total over sample size. If you do the same procedure for the other two boxes, you'll get, let's see, for this one you'll get 62.36. Guess I'll do another color, and for this one you will get 28.36. So remember that we can construct a table to find our test statistic. So the test statistic needs a column of observed, a column of expected. If you want, you could do observed minus expected squared and observed minus expected squared divided by expected. So we had 27 that was observed for Stark and jail, but expected was 29.64. For Stark and another sentence, it's 65 with 62.36. For Rivera and jail, it's 31 with 28.36. And for Rivera and another sentence, it's 57 and 59.64. So So if you do these computations for these other columns, you're going to get, filling in the rest of the columns, you will get basically 6.97 on every single one of these. But the next column will become 0.235, 0.112, 0.246, and 0.117. So in this column, remember, you're dividing by expected value for each, which is what's changing it. So when we sum, we don't need any of these sums. We just need the sum of this last column, which turns into basically 0.710. There's some rounding there just from doing in Excel. So this is our chi-squared test, which is quite small. Remember, the closer it is to 0, the more similar the observed and expected outcomes are, which is not strong evidence of dependence. Okay, so to complete it, we need chi-squared critical, which comes from r minus 1, columns minus 1 for degrees of freedom. We had 2 rows and 2 columns, so we only end up with 1 degree of freedom. And with 1 degree of freedom, our critical value is 3.841. So once our test statistic is past 3.841, we would reject the null. But we have a test statistic way down here at 0.71. So we're not even close. We do not reject the null at 5% level of significance, which means that we cannot show that sentence and the judge are statistically dependent.